The power rule. All right, here we go. This is a big one. All right, so if you take the derivative, n is a rational number, then x to the n is, and x to the n is differentiable. So if you take the derivative, x to the n, you drop the n in front, and then subtract one from your exponent. So right away, we've got a just a basic x squared, and we could prove this. I mean, you could. There's a way to prove it. The general form. It's lengthy, but you don't have to. We've got it. So y prime is going to equal, you drop your exponent down, and then I'll actually show that subtraction. Then you subtract 1 from your exponent. So this is 2x to the first, also known as just 2x. Okay, so the derivative of x squared is 2x. All right, what about the derivative of x to the fourth? All right, drop your exponent down, which is interesting because you kind of are used to that when you did logarithms, but you weren't used to doing this. So I dropped the 4 down and I subtracted 1 from the exponent. Uh-oh, we have to have an exponent before we can drop it down. Okay, so y prime, and here's the deal. There's a bunch of different ways I can write this. So I've got 1 half x to the 1 half minus 1. All right, so this is 1 half x to the negative 1 half. But hold on a second. That's the same as 1 over 2 times x to the 1 half, using your exponent rules. But wait a second. That's the same as 1 over 2 times the square root of x. And usually they don't make you rationalize the denominator. But if they did, you'd multiply top and bottom by the square root of x, would you not? So you'd have the square root of x over 2x. I'm just going to be honest. They really don't make you do that a whole lot. This is good. That's good. I mean, that's even okay. I mean, any of these are fine. So you got 1, 2, 3, 4 different ways to write that answer. Uh-oh. Got to have an exponent before we can do the power rule. Got to have a power, all right? So here we go. So g prime of x is going to equal -1 x to the -1 minus 1, which is negative x to the -2, which is okay by me, but you might see this as -1 over x squared. Okay. All right. This is the same as x to the -2. And away we go. So f prime of x is going to equal -2 x to the -3. I'm just going to go, not going to write the subtraction this time. And that would be -2 does not have a negative exponent, but the x does. So it goes to the bottom. There we go. All right, f. We have x to the -2/3. All right, so y prime, or dy dx, I'll put y prime, is going to be -2/3. Drop your exponent down. Careful here. X to the -2/3 minus 1. Well, -2/3 minus 1 is -5/3. All right, so this could be, I could have -2 up top. On the bottom, I could have 3x to the 5/3. And I don't think I want to do anything with like that 3 being a cube root. I mean, you could do that. I said I didn't want to, but I'm going to. That would be fine. I really think they would just kind of leave it like this. Honestly, I don't think they'll do a whole lot of that. Lies. So -2 and 3 times the cube root of x to the 5th. And I know you're thinking, wow, I could pull out some x's because it's a cube root. Let's do it. Okay. So I could go -2 and then 3. And then I could pull out one single x because the cube root of 3 of those would just be x, and that would leave me with 2 remaining under the radical. Man, I just can't imagine a lot of that happening. Okay, so that's example 3 with the power rule. All right, and once you do the power rule to begin with, you've answered it. You really have. What's all this cleaning up? Probably not necessary.